So in this video, I want to show you the basics of quadratic functions that we've been looking at. So we're going to look at the notes activity that I've shown in class. Starting with the first paragraph, quadratic function looks like this: ax squared plus bx plus c. You have a quadratic term, which is the x squared term. A cannot be 0. There has to be an x squared term. So keep that in mind. Let's see, next. There's a linear term, and there's a constant term. So the keys are the A, the B, and the C. We're going to need to know those values of those coefficients so we can do some things later on. So again, let me grab my pen tool. This is key here, knowing what a quadratic function looks like in standard form, ax squared plus bx plus c. So let's slide. Now let's go up here. Guess that's not working. Let me go back and grab my mouse here. Let's move up. So we had looked at filling in t-charts just like any equation. You have inputs, outputs, and a function. Every one input only gives one output. And as we looked at a couple examples, we noticed that the graph of a quadratic function is a parabola. And a parabola either opens up, as this one right here does, or it can open down, as this example right here did. And not only does it open up or open down, it is a mirror image of itself if it's reflected over an axis of symmetry. So the axis of symmetry I have highlighted in yellow. And we looked at those lines of symmetry in the other examples. Now, to find the line of symmetry, there is a formula we use. Okay? And that formula is right here. It's the opposite of the opposite of b over 2a. So you find the b, which is next to the x, and you put that in the numerator. You take the a, which is the coefficient of the x squared term, it goes in the denominator times 2, then you use its opposite. And that will give you the line of symmetry equation because it'll be x equals. And we all know that any equation that has x equals will be a vertical line. And a line of symmetry is a vertical line. So let me go back. So we have our vertical lines in yellow. Those are our lines of symmetry. Okay? Then we talked about every parabola has a bottom. If it opens up, there will be a bottom point. Or if it opens down, it has a top point. That point is called the vertex. The vertex, as you see over here, is this point right down here. I have it highlighted in like bluish. And to get the vertex, it's on the axis of symmetry. So you already know what the x term will be because the axis of symmetry is an x equals equation. So you take that x value and you substitute it into the quadratic equation. Just like any input, out comes an output, which would give you the ordered pair for the vertex, which I'm trying to highlight right here. So let me go over that with an example down below. So we were given a quadratic. We found, using the formula, we found the axis of symmetry, which is x equals -3, and I put that in yellow. See it right here, it's in yellow, right there. And then what we did was we took that x equals -3, we substitute -3 in where the x's are, and out came in -11. So we have this ordered pair, and that becomes your vertex. And then from the vertex, you need to find one more point, and a great point to find is the y-intercept, because any y-intercept is where the x is 0. So just substitute a 0 in for the x, and you get your y, and you have your y-intercept, which will be right here at 0, -2. And since a parabola is symmetrical, you reflect it over the line of symmetry, you have a second point, and you can then, if I could just stop this from moving on me, you have this parabola that is formed. This one opens up. And we took a look at a couple examples. We took another one here. This one opened up also. Okay? And then we actually graph one together. This negative 5x squared minus 10x plus 6. We found the axis of symmetry, which was x equals negative 1. It's right through here. Let me grab my pen tool, make it yellow. So this is the axis of symmetry. We got it from here. And you use that value, you substitute it in where the x is, and you get an output, and that gives you the vertex, and the vertex is right up here. Then you find another ordered pair, like substitute in 0 for x, you get a 6. That's called the y-intercept. That's right here. And you just reflect it over here, and you have yourself a parabola. Then the last thing, let me go back here. The last thing we talked about was maximum minimum values. And this key concept box in our notes explains that if you have a parabola that opens up, the A value will be greater than 0, and greater than 0 means a positive. So anytime you have a positive A, you're going to have a parabola that opens up. Then it says it opens down if the A is less than 0, which means it's a negative. It'll open down. And if it opens down, the value for y is a maximum because it doesn't go any higher. That's the highest y value that could be. All the other y's are less than that. If it opened up, the y value here for the vertex is a minimum value because all the other y's are going to be greater. They're going to be up above.